Hi, welcome to RoboJax. In this video we are going to build this DS0138 oscilloscope kit. So this is a kit that is sold between $20 to $50 in different markets, and it's amazingly solid. You learn how to assemble it from that, and also you will also can use it practically. This can measure up to 200 kilohertz. So that is enough for a beginner to learn electronic. Bandwidth is about 200 kilohertz, and it has multiple switches for selecting the sensitivity. So two sensitivity, one would be the probe multiplication, and also multiply by 1, 2, and 5, and also 10 millivolts, 100 millivolts, and 1 volts selection, as you can see here. DC coupling switch here, DC AC. Then we have a test point here, which gives you 1 kilohertz square wave, and then we have 4 buttons with a 1 reset. So these buttons are for selecting period and trigger mode and some other options. When I press this button here and hold it, it shows full detail of the waveform. For example, it shows now the frequency, the period, the duty, which is 50% up and down, and then the amplitude, all those information. Now it shows its hold. So if I press it again, now the value is real time. So if I change from my oscilloscope, now it's 9 kilohertz. It's exactly the same that I have on my Tektronix oscilloscope. And then finally we will build this case, so the oscilloscope is protected and nicely. And then finally we will build this case, so the oscilloscope is protected and nicely. And then finally we will build this case. Let's get started building this. Select it. So this is DS0138 kit. So this is the first, and it comes with nice manual, properly printed. So this one, it says SMT component installation guide. So on this side we have Chinese, and this side it's English. That's one sheet. DS0138, that says, it says user manual. So from here it says step 1, step 2, it explains it, but this side is also continuous, so it's up to step 22. So a lot of explanation and also troubleshooting. So this is very nice. Now we also have a schematic diagram which explains how this has been assembled, and also here connection, controls, and operations, how to use the oscilloscope. So this is the display. That's very nice to get the signal out with BNC connector and alligator clips. And this is the main board, as you can see, DS0138. It's double-sided PCB with a main chip, which is very hard to solder. So the chip is already installed. And the components are, all the components are here. So let's just follow the instruction and start building it then. According to this note, it says that SMD component, the surface mount devices, must be installed prior to the installation of through-hole component, which means all other components should be installed later. So I have to do this, which I have to follow these components to be installed first in this section. But I've already installed the resistors, which I noticed after that, so that is still not an issue, because they are not blocking my path in soldering. U3 goes here, and that is U2. U2 goes here. This is U1, which you don't have to do it, and the rest of the components are here. They are all labeled properly. Moving first the 10 kilo ohm resistors on this side. I'm just removing it like that, and then we can remove it with a flat screwdriver and then pop it out with tweezer. So we need 6 of those, so 5 here and then 1 more from there. So the first one, so let's say R17, 20, 23. I'd like to also explain the resistors. For example, this is 332. So 3 is also 3. The second digit is digit. The 2 is number of zeros. So this is 3300 ohm or 3.3 kilo ohm. While this one is 103. That 3 is the last digit is number of zeros. This is 10 kilo ohm. The other one is, you can see, 152. That is 1500, 15 and then 2 zeros. So let me clarify the value for the 22 ohm, as you can see here. So we have 2, 2 and then 1, 0. The 0 at the end means no digit, nothing. Kilo ohm resistor, I'm putting it here. So this is the R17. That's the spot. So R17 is a 10 kilo ohm. So first you have to apply a little solder there. That's done. And then put this and solder it. So I will hold it with tweezer. Hopefully I can do it with my left hand. So one side is done, then the other side will be very easy. So that has been soldered. So we had our 17, 20, 34, 35 and 41, R17, R20, R23, R34, 35 and R41. 19, 22, 25, 31, 1.5 kilo ohm, 19, 22, 25 and 31. So we have 1 kilo ohm, 27, 32, 33, 42. So here is 27, 32, 33 and 42. R18, 21, 24 are 3.3 kilo ohm. So R18, R21 and here is R24. R29 and R30 are 22 ohm. So R29 and R30 are here. Now this is a U2 spot for the U2 for this chip, and notice that there is a small notch here. So the same way that there is a small dot, so this must be this way, because this is pin 1 and so forth up to the end. It counts like that. So this goes exactly here. So you put it and align it properly and then solder one side once it's soldered, then solder the other side and continue. So we have to start at one point. So just, let's say, I'm just attaching one solder here, so that is enough to hold this for me. make sure that this is aligned, all the pins are properly aligned, because once you solder it, then you cannot move it. So that pin has been attached. So now one pin is attached, and now I'm gonna apply the solder into the other pins slowly. So if the two pins got together, just clean the soldering iron and then come back. So that has been cleared. Now I'm soldering this side. So this chip have been now soldered. Let me zoom in so you can see it. Now I'm soldering this U3. So this is the spot, the same way one spot should have some solder, and then put that so I have applied solder at this spot. Now I'm just holding it to make sure that this is attached here, and then now giving some solder here. So this is also done. To check the each resistor, you need a multimeter, because this color, the blue color of these resistors, these are metal film, not carbon film. The colors are not easily identifiable, so you have to check on one side. On the other side, make sure that your finger does not touch, because for the higher value, you see here, even if I put my hand, you can read some value. So this is disturbing the calculation. So make sure that one side, if you hold with your hand, the other side should be just free. For example, this shows 180 ohm. So this is the 100 kilo ohm. So we have three of those 100 kilo ohm. That is R1, R14, and then here R16. So R11 is here, 150 ohm. R3, 200 kilo ohm. So this is R3. So 1.5 kilo ohm is R38. So that's the R38. R5 is 20 kilo ohm, and here it is located. We have R8, 12 and 13, 120 ohm. So R8, and here is 12, and here is 13. R2, 1.8 mega, here. R37, R39, 10 kilo ohm. Here is 37 and R39. So we have R9, R15 and R26, 1 kilo ohm. So that is R9, this is R15 and that is R26. R4 is 2 mega ohm and here is the location. R10 is 3 kilo ohm and here is the location. R7 and R36, 180 ohm. Here is R7 and here is R36. So R28, R40 is 470 ohm. So that is 28 and that is R40. I've attached all these resistors that are listed here, all of them. And on this side they are like this. So now I'm going to solder them all. Now I'm attaching these 3 inductors. They call it RFC choke. I've soldered now L3, L1, L4. So these are the same value. I just soldered them here. So now we have the diode D1, D2. So D1 goes here, which is labeled as 5819, and D2 is 4004 in here. So these 2 diodes, these are the diodes, and if you look carefully, they are exactly the same except the numbers are different. So I'm just following the same number and soldering it. One thing to pay attention is that is cathode, so there is a line. Make sure that you put it in the same direction, the same way for the other one. Now I'm gonna solder the 8 megahertz crystal. So this is a crystal. It is written 8 megahertz and it goes here. And here is a USB connector. USB connector goes here. This is optional, but I'm gonna install it anyways. So just insert it, make sure it's held. So now this is holding itself. It doesn't need any help. Now I'm gonna solder these push button switches of SW4, 5, 6, 7 and 8. So they go here. Because we are connecting one of the pin to the ground, so the switch doesn't need to have any direction, although the switch has its own characteristic to be used specifically, but because it doesn't matter here, we just put it in any way you wish. For these ceramic capacitors, we have to make sure that you cannot push it, otherwise if you push it too much it can break. So be careful not to push it too hard, just leave it a little high. That's enough. And then bend the pin and solder it. So the rest of these capacitors, are 0.1 microfarad or 100 nanofarad. So 100 nanofarad is 100,000 picofarad. So this is 104, very faded written on it. So 4 means 4 zeros. So 10 plus 4 is 50 with a 1. So this is 100,000 picofarad or 100,000 picofarad or 100 nanofarad or 0.1 microfarad. C1, C9, C10, C11, C14, C15, 16, 17, 18, C20, C23. C2 is 330 picofarad and it is written as 331 and C2 goes here. So C3 is 3 picofarad, it has just the number 3 on it and it goes here, C3. So C5 is 1 picofarad and it's written 1, it goes here. So C7 and C8 are 120 picofarad and as you can see it's written as 121. So C7 is here and C8 is here. C12 and 13 are 22 picofarad, so they have 22 written on them. And here is C12 and C13. Now I'm soldering the LED here, the light emitting diode. In here, the longer pin is positive, and that should be on this side. This is the pin header, J9 will be here, soldered here. These two transistors of Q1 and Q2 are going here, and according to the manual, Q1 is 8550, Q2 is 9014, and it is written on them. The way you put it is the flat side should be here, as you can see, and the round side should be there. I'm inserting these two voltage regulators. One is 7805, one is 7809, so they go accordingly. 7905 goes here and 7805 goes here. So these are 5-volt regulator, one is negative, one is positive. So C4 and C6, so these are two variable capacitors. So L2 is a 1 microhenry inductor, doesn't have any polarity, and it goes here. So we have 6 100 microfarad 16 volt capacitor. It has polarity, so it has negative and positive, and also positive has a longer pin. So here, if we count them here, 1, 2, 3, 4, 5, 6. Make sure to pay attention for the polarity. It is clearly labeled as plus on that side. So the DC power for the 9-volt jack now will be inserted in here. We will cut from this header 3 pin and then 4 pin. 4 goes here and the 3 goes here. So we will use this 2 pin and then this 20 pin header. These two will go here at J7 and J7 and 8, and this the big one will go here. Now I will insert the switch here, so make sure to understand that there are missing pins here, so 2 pin is together and 3 is on the other side. So just insert it and then solder it here. And then insert these 2 switches, one here and the other one here. Switch has been soldered now. And now we need to connect this BNC here. Make sure, because this is all metal, it will not get soldered, so you have to hold it for a long period until the heat reaches here and it gets heat up. So I just forced it to make sure it fits. So you have to hold this for long. So let me just solder this first. Now for this I will hold it longer. Now here, so BNC connector is also soldered. Just clip this excess of pin here. It's very hot yet, I'm not touching it. We can create a U-type from this. Just bend it and then insert it there and solder it. This will be a test point. So we will have it a little longer. So now we have a test point here, as you can see. And now let's just shorten these two with the solder. Now connecting the 9 volts here, and after connecting it, it says that check at this test point here at this TP22, and by connecting the other pin to the ground to make sure that we get 3.3 volts. So here I have 9 volts here, negative and outside, and then inside I'm connecting it, so that's 9 volts. I'm connecting it there. To measure the voltage at this point, so the positive is here, the positive is here. For the negative you can put it at this point, or here it says ground, or connected to this part. All of them are good, so I'm just holding it here like that, and then just measuring here, make sure it shows 3.3 volts, so 3.27, that's good. Now if this is 3.3 volts, then it says solder this test point here. Just solder, there are 2 points, solder them. So beside the crystal, this test point, just solder these 2 points. You can see now it has been soldered. Now it's time to insert the LCD. So this goes in this area, and these 2 pins will be inserted at these 2 female headers. Make sure that this is aligned. Here also it's aligned, so everything is good. Just push it. So now the LCD is in place. So that's good. This is working now. So oscilloscope turned on, and it's color. So yes, the first thing that when you touch it, if it works, you should get this is the noise of AC signal around. So it got fixed. Now let me connect it. Okay, so now let me select. Thank you for watching. Please thumb up the video, and also please subscribe so you can get updates of my upcoming videos.